In this Q&A video, we're going to answer the question, what is a clean earth? Now, just before we explain the answer to this question, please be aware that this video is one of a series that we've made on the subject of underfloor to desk wiring systems. They can be viewed individually, or you can click the link in the description below to view them as part of a free online training package to help you with your CPD and receive a certificate to prove you've completed the course. You may have noticed in other videos in this series that the PowerTrack that sits at the core of this system from Marshall Toughflex has a couple of variants. One of them has grey coloured tap-off points and the other has these red ones. That's because the red version is a clean earth system. First of all, let's outline the problem that we need to solve with this clean earth system. A lot of electrical equipment produces electromagnetic contamination, or EMC. This basically consists of magnetic fields that cut across conductors, and when this happens, it generates or induces current inside the conductor. The induced currents are transient in nature and will come and go depending on how the equipment generating them is behaving. They're also referred to as noise in the system. In mains conductors that are already carrying current, this isn't generally a huge deal. However, installations should be designed to try and reduce EMC in the first place. The bigger potential problem occurs when this current is generated into the conductors that form the earthing arrangement and then get conducted around the system. Many forms of IT equipment rely on a good connection to earth in order to function properly, and if they're connected to circuit protective conductors that have transient current spiking in them, it can seriously disrupt the way they work and even, in extreme cases, damage them. So in a large installation, it may become necessary to supply critical IT equipment with a connection to earth that has this electromagnetic contamination reduced. Theoretically, this could be done by installing a completely separate earthing arrangement to the installation that had no connection to the sources of EMC and only connected to the IT equipment that needed protecting. While this wouldn't remove the problem entirely, it would certainly reduce it. However, we can't do that because BS 7671 pretty much forbids having two separate earthing arrangements in a single installation. This makes perfect sense because a rise in voltage on one of the earthing systems wouldn't show the same rise on the other, and you could very easily get a shock from one to the other. So there's a kind of halfway house approach using what's probably more accurately referred to as a low noise earth, or as we know it better, a clean earth system. This is where a separate conductor is installed alongside this EPC and connects to the earth terminal of the IT equipment you're seeking to protect. This separate CPC will still be connected to the normal earthing arrangement, but not at the point of use. Much like a regular earthing arrangement where you have a main earthing terminal, then distribution conductors to other earthing terminals and final circuit connections, depending on the size of the installation, there will usually be a clean main earth terminal from which clean distribution earthing conductors will be run out to other clean earthing terminals and onto final circuit clean earthing conductors. This main clean earth terminal will be located near the main earth terminal, and these will be connected together here and here only. There will be some conduction of the EMC currents onto the clean earth system and some induction on there as well, but it's very much reduced. For the final circuits to the PowerTracks, a separate clean earth conductor is run out to the end feed unit and then connected to the centre terminal of the connection block. You can see quite clearly here that the terminal for the clean earth is marked a little differently to the normal earth terminal. On the normal terminal, the earthing symbol is enclosed in a circle. On the clean earth terminal, it's got a half circle identifying it. So the clean earth conductor will connect to that centre terminal and the regular CPC connects to one of the outer terminals. Keep in mind though that there's absolutely no electrical connection between these two terminals except back at the main earthing terminal. I should say at this point that there are other ways of achieving a clean earth where you can be a little less rabid about this separation, but this is the basic principle. From there, the tap-off points have an extra connection inside them, the general earth connection, which is picked up from the metal bodywork of the track, and the clean earth has its own separate buzz bar on the inside, and the tap-off points and connectors feature an extra terminal and pin to carry the clean earth connection through separately. You can see the extra conductor poking out of the end of this flexible conduit, coloured black with a bit of green and yellow sleeving and a clear label stating this is a clean earth. That's a really neat solution to make it clear which earth conductor is which, while still complying with the requirements for identification in BS 7671. Now, obviously, there's no point in having the two separate CPCs all the way from the main earthing terminal all throughout the entire system, only to have them joined together at the load. And this can be particularly challenging at a socket outlet. If we take a look at the front of these two sockets, they look very similar apart from two key details. One is this red dot, which is how Marshall Toughflex identify their clean earth components, and the other is that these screws holding the socket outlet to the faceplate are metal on the standard socket and plastic on the clean earth variant. So why is that significant? Well, flipping them over, you can see the red sticker on the clean earth socket was sitting over the fixing of this earth terminal on the front plate, which is missing from the standard socket. Again, this is about maintaining that separation between the clean earth and the regular system. The metal bodywork of the socket and the floor box it sits in are exposed conductive parts and so need connecting to the general earthing system, and that's what the connection on the front plate is for. But the earth terminals in the front of the socket need connecting to the clean earth system, so the terminals on the socket itself are used for this purpose. However, pretty much all sockets have this metal strip across the back, which in general installations earth the back box via the fixing screws. However, in our clean earth system, this would simply connect the clean earth to the general earth, and that's why the clean earth socket has these plastic screws, so there's no electrical connection between the clean earth in the socket terminals and the general earth on the front plate. Clever stuff. So there we go, that's what we mean by a clean earth. Now this PowerTracks system is great where you've got a floor cavity, however where there's no raised floor we can use an alternative in-screed trunking system. To find out how to calculate the number of conductors we can install in them, check out this video right here or click the link in the description below to watch it as part of our free training package to help you with your CPD and receive a certificate as well. All that remains in this video is to say thank you very much for watching.